LangGraph state management system employs a hierarchical composition pattern where independent state machines can be nested within parent graphs, enabling modular workflow design through controlled state transformation. This artifact demonstrates the foundational mechanism of subgraph integration, where a child graph with distinct state schema is invoked from a parent node via explicit state mapping. We will examine how a subgraph is constructed with its own state typology, compiled into an executable unit, and then invoked from a parent graph node through bidirectional state translation. The implementation reveals how LangGraph maintains isolation between state schemas while facilitating controlled data flow between hierarchical graph layers.
From typing extensions, import TypedDict. From LangGraph, graph state import StateGraph start. Class subgraph state TypedDict. Bar str. Hash subgraph. Def subgraph node 1 state. Subgraph state. Return bar. Height plus state bar. Subgraph builder equals state graph subgraph state. Subgraph builder. Add node subgraph node 1. Subgraph builder. Add edge start. Subgraph node 1. Subgraph equals subgraph builder. Compile. Hash parent graph. Class state TypedDict. Foo str. Def call subgraph state. State. Hash transform the state to the subgraph state. Subgraph output equals subgraph. Invoke bar. State foo. Hash transform response back to the parent state. Return foo. Subgraph output bar. Builder equals StateGraph state. Builder add node. Call subgraph. Builder at edge start. Node 1. Graph equals builder compile.
This code demonstrates the foundational pattern of subgraph integration in LangGraph, where a smaller graph subgraph is invoked from within a node of a parent graph. The subgraph operates with its own isolated state schema, subgraph state with bar key, while the parent graph uses a different schema, state with foo key. The integration happens through explicit state transformation in the call subgraph node function, which maps the parent's foo value to the subgraph's bar input, and then maps the subgraph's bar output back to the parent's foo state. The key mechanism here is the encapsulation boundary created by the subgraph. The subgraph maintains complete isolation. Its internal nodes, subgraph node 1, only see the subgraph's state keys, while the parent graph remains unaware of the subgraph's internal structure. This isolation enables clean separation of concerns and independent development, which is particularly valuable for multi-agent systems or when different teams own different components. The trade-off is the explicit transformation logic required at the integration point, which adds boilerplate but provides clear control over data flow between the graphs. This pattern is chosen when you need strict state isolation between components, as opposed to the alternative approach of shared state schemas, where subgraphs can be added directly as nodes. The isolation comes at the cost of requiring transformation logic, but gains you modularity and the ability to evolve subgraphs independently as long as their input-output contracts remain stable. In production systems, this pattern becomes especially useful when subgraphs represent distinct functional domains, or when you want to enforce clear API boundaries between components. Let's break it down.
From typing extensions, import TypedDict.
Imports TypedDict from typing extensions to enable type hints for dictionary structures with specific key-value type constraints.
From LangGraph, graph state import StateGraph start.
Import StateGraph and start from LangGraph, graph, state module. StateGraph is a class for creating stateful graph structures, and start is a constant representing the initial node in such graphs.
Class subgraph state TypedDict.
Defines a subgraph state class that inherits from TypedDict, indicating it will be a dictionary-like structure with type annotations for its keys and values. This establishes a type-safe state container where each field's name and type can be explicitly declared, enabling static type checking and IDE support for state management in the subgraph.
Def subgraph node 1 state. Subgraph state.
Defines a function named subgraph node 1 that takes a single parameter state of type subgraph state. The function signature indicates this is likely a node in a graph-based workflow, where state represents the current state of the subgraph execution.
Return bar. Height plus state bar.
Returns a dictionary with a single key bar whose value is the string high, concatenated with the current value of state bar. This operation preserves the existing state while prepending a greeting to the bar field.
Subgraph builder equals StateGraph subgraph state.
Creates a StateGraph instance named Subgraph Builder that will manage state transitions using the Subgraph state class as its state schema. This initializes a graph structure where nodes represent states and edges represent transitions, with subgraph state defining the data model for the state objects.
Subgraph builder. Add node subgraph node 1.
Adds subgraph node 1 to the graph being constructed by Subgraph Builder. This single line registers the node within the builder's internal structure, making it part of the subgraph's topology. No additional configuration or edge creation is performed here, just the node's inclusion in the graph.
Subgraph builder. Add edge start. Subgraph node 1.
Adds a directed edge from the start node to the node named Subgraph Node 1 in the graph being constructed by the Subgraph Builder. This establishes a connection where execution can flow from the graph's entry point to the specified node.
Subgraph equals subgraph builder. Compile.
Calls the compile method on the Subgraph Builder object, which processes the subgraph configuration and returns a compiled subgraph instance ready for execution. The result is assigned to the variable subgraph, which now holds the executable subgraph structure.
Class StateTypedDict.
Defines a state class that inherits from TypedDict, indicating it will be a dictionary-like structure with type annotations for its keys. This establishes a type dictionary for state management, where each key will have a specified value type.
Def call subgraph state. State.
Defines a function named callSubgraph that takes a single parameter, state, with type annotation, state. The function signature indicates it will operate on a state object, but the implementation details aren't visible in this segment.
Subgraph output equals subgraph. Invoke bar. State foo.
Invokes the subgraph with a dictionary input containing a single key, bar, whose value is taken from state foo. The result of this invocation is stored in the variable subgraph output. This demonstrates passing data from the current state into a subgraph for processing, with the output captured for potential further use.
Hash transform response back to the parent state. Return foo. Subgraph output bar.
Returns a dictionary with a single key, foo, mapped to the value of bar from the subgraph output dictionary. This transforms the subgraph's output structure into the expected format for the parent state, effectively passing the bar value up the call chain under the new key, foo.
Builder equals StateGraph state.
Creates a StateGraph instance using the state class as its state type. This initializes a graph structure where nodes will process and transform state objects of type state.
Builder add node. Call subgraph.
Adds a node named Node1 to the graph builder that executes the call subgraph function when invoked. This establishes Node 1 as a processing step in the workflow that will trigger the subgraph execution.
Builder at edge start, Node 1.
Adds a directed edge from the start node to the node named Node 1 in the graph being constructed by the builder. This establishes that execution should flow from the graph's entry point to Node 1 as the first step in the workflow.
Graph equals builder compile.
Compiles the graph constructed by the builder into an executable workflow. The compile method processes the graph definition created through the builder interface and returns a ready-to-execute graph instance that can be invoked or deployed. This is the final step in graph construction before execution. This implementation showcases LangGraph's hierarchical state management through subgraph integration, where independent state machines maintain isolation while enabling controlled data flow. The subgraph operates with its own subgraph state schema, completely isolated from the parent's state schema, enforced by explicit state transformation in the call subgraph node. This design choice prioritizes modularity and separation of concerns, allowing subgraphs to evolve independently as long as their input-output contracts remain stable. The trade-off is the required transformation logic at integration points, which adds boilerplate but provides clear control over data flow between hierarchical layers. This pattern becomes particularly valuable in multi-agent systems or when different teams own distinct functional components, as it enforces clean API boundaries while maintaining the flexibility of graph-based workflows.
The subgraph stitches bar into foo's shadow, but the parent graph only feels the seam.